Hello everyone. Today we have with us Khan. So he'll be talking to us about the new things introduced at TensorFlow Lite from Dev Summit 2020. So Khan is a developer advocate at Google, and you might have seen him, talking about TensorFlow in various forums. I remember meeting him at the India ML DevLite Summit last October in Bangalore. He was also there for the TensorFlow Roadshow Bangalore, which was one of the greatest TensorFlow events in India so far. So today, before we start, so hi, I'm Anubhav Singh, right? I'm one of the core team members at TensorFlow User Group Kolkata, and along with me today, there will be four other people who are handling the stream. Shag Paul, who is the organizer at TensorFlow User Group Kolkata, Avijit, Ayush, and Shivam, who will be taking care of the comments which are coming in, any queries which are coming in. They will be moderating the chat, and they will also be helping Khan deliver this session without any interruption. Just a quick, you know, self promo plugin here that I'm very proud to say that I have, completed this book, Mobile Deep Learning with TensorFlow Lite, MLKit, and Flutter. So if you want to get this book, just go to the link provided on the right side, bit.ly/TFLite book. And I'm sure you will find this book useful for implementing TensorFlow-based solutions into your mobile apps using Flutter or even without using Flutter. So yeah, please do go ahead and read this book, leave a feedback, leave a review for me to understand how you like the book. And now we'll be moving towards Khan's session, and I won't take more of your time. So Khan, over to you.
Hi, Anurag. So hi everyone. My name is Khan, and I'm a TensorFlow developer advocate based in Tokyo. And today, I would like to start by thanking the Kolkata TensorFlow user group for hosting this online event. And it's my pleasure to talk with the TensorFlow users in India. As was introduced earlier, we had the TensorFlow Dev Summit earlier in March. And in Dev Summit, we had announced quite many new features and improvements to TensorFlow Lite. And we had a total of three-four TensorFlow Lite sessions. So today, I would like to do like a quick summary of all the things that we have announced at Dev Summit and deliver it in a 20-25 minute session for you. Okay, so let's start. First of all, what is TensorFlow Lite? I think many of you may have already familiar with it, but let me just do a quick introduction of TensorFlow Lite for those who don't know. So TensorFlow Lite is our production-ready framework for on-device machine learning. It supports Android, iOS, Linux, and other platforms. Let's talk about the need for TensorFlow Lite and why we built an on-device machine learning solution. So we are seeing a huge demand for doing machine learning on the edge to implement use cases that require low latency, that work without internet connection, and that preserve user privacy. So all of them are the reasons why we decided to build TensorFlow Lite. So we started our journey in late 2017. And as the world-leading machine learning mobile framework, we have made a lot of improvements across the board. And TensorFlow Lite is now deployed on more than 4 billion devices around the world across many different apps. And many of the Google-owned largest app is now using TensorFlow Lite, and also many apps from external developers. This is some examples of the apps that are currently using TensorFlow Lite. It includes Google Photos, Gboard, YouTube, Google Assistant, and then along it is several popular third-party apps such as Uber, Hike, Airbnb, and so on. So what is TensorFlow Lite being used for? Many developers are using TensorFlow Lite for use cases around image, text, speech, but we are seeing a lot of new and emerging use cases around audio and content generation as well. So let me do a quick demo on what TensorFlow Lite can do for those who are new to it, and so that you guys can get a sense of like how it works. Let me see how I put my screen here. Okay. So screen. Okay, cool. I think can you see my phone screen? Okay, cool. Okay. So what you can see now is that I have my phone here on airplane mode, so no internet connection. And let me show you a quick demo of what TensorFlow Lite can do. So the first demo that I want to show you is a question and answers app. What it can do is we have a TensorFlow Lite model that runs on the device that, for example, can take any body of text, and then you can ask them questions related to the text. So this is a paragraph about Nikola Tesla, and let's try to add a question. So let's try. Who is Tesla?
A Serbian-American inventor.
Yep, you can see that it got it right. And try more. Try another one. Let me use this keyboard. Okay, when did Tesla die?
7 January 1943.
Yep, and you can see that it all on the device. Okay, so let me do another demo. So this is a style transfer app that can take any image and turn it into an artwork. So let me take a photo. I will have one, but let's just take a photo. And then I choose a style. And then you can see that it applies the style here that I chose on my image. And all of that has just happened on the device. Okay, so I hope that with the demo, you now get a sense of what is possible with TensorFlow Lite. And let's get back to the presentation. Okay. So we want to continue to grow the number of on-device machine learning use cases by making TensorFlow Lite more robust while keeping it simple. And in the next 20 minutes or so, let me share with you the new products and features that improve TensorFlow Lite user journey. First, to make onboarding easier for new users, we have recently updated the learning materials on TensorFlow website. And we also launched a new free course to learn TensorFlow on Udacity. And in addition to tutorials and code lab, we also have a list of sample apps and pre-trained models across a variety of use cases to have you ramp up quickly. And we will continue to release new samples and new models to enable new use cases. And not only that, you can use the pre-trained model and the sample apps. You also can customize those models with the new tools that we just launched and use the models on your own data. You also can package and share the models with other users easily. And once you have made the choice of either using a pre-trained model or customizing an existing model for your own needs, we have introduced a new set of tools to make it easier to use this model within an Android app. And finally, TensorFlow Lite is not only cross-platform, but it also supports hardware accelerators that are specific to each platforms. And next, I'll walk you through each of the updates in more detail. Okay, so let's start with onboarding. We know that on-device machine learning has only started to pick steam. So we want to make sure that there are good learning materials to have you get started with on-device machine learning and TensorFlow Lite. We recently launched an Introduction to TensorFlow Lite course on Udacity. And we also updated the code labs and tutorials on the TensorFlow website. So for example, the code labs that you see here is an end-to-end code lab that shows you the process of training a TensorFlow machine learning model that can recognize handwritten digit and convert it into a TensorFlow Lite format and then deploy it to an Android app. Once you have familiarized yourself with TensorFlow Lite and you have decided to start prototyping your use case, we have a list of sample apps that showcase what is possible with TensorFlow Lite. So instead of developing your apps all from scratch, you can select a sample app that is closest to your use case, and you can see how TensorFlow Lite performs on actual devices. So we have released a couple of new samples, such as the style transfer sample that I just show you. It's also on the screen right now, which you can convert any image into an artwork. And in addition to the sample apps, there are also a bunch of new pre-trained model, both from Google and from the TensorFlow communities that you can leverage. They cover a variety of use cases, from computer vision to natural language processing and speech recognition. And you can discover this model through either TensorFlow Hub, or through our TensorFlow.org website, or through a GitHub repository. Sorry, this is a little bit hard to see, but we have a GitHub repository called Awesome TFLite that one of our TensorFlow ZDs has put together. And machine learning is a very fast-moving field with breakthrough research released every few months. So we want to make sure that TensorFlow Lite fully supports those state-of-the-art models coming out of research. And you can quickly apply those models to production. Here's one example. FGNet Lite brings the power of FGNet, which is a state-of-the-art image classification model, to edge devices, and it comes in 5 variants. So you can choose between the low latency model, and it's also like pretty small, to the high accuracy option. The largest variant, which is FGNet Lite 4, is achieves the integer quantized version of FGNet Lite 4 achieves 80.4% of accuracy, and it's still running pretty fast, which is like less than 30%. 30 milliseconds on a Pixel 4 CPU. And you can see from this chart how FGNet Lite has outperformed the existing very popular image classification models such as MobileNet all the way up to Inception before. And in addition to ensuring that state-of-the-art model can run well on TFLite, we also want to make sure that you can easily customize your state-of-the-art model so that it can fit for your use case. And that's the reason why we launched TensorFlow Lite Model Maker, which enables you to customize the state-of-the-art model with your own dataset, and it requires no prior machine learning expertise. Here's the amount of code that you have to write in order to train an FGNet Lite model on your own dataset without TensorFlow Lite Model Maker. But with Model Maker, it's just 4 lines of code. So you start with specifying your data set, and then you choose the model specification that you want to use. In this case, we use a default one, which is TFLite 0, and then it just works. And next, you can run the model on your validation dataset to measure its accuracy. And finally, you can export it into the TensorFlow Lite format to use in mobile apps. And in on-device machine learning, you have to constantly make a trade-off between accuracy, inference speed, or model size. So that's why we want to make sure that you not only be able to customize the model with your own dataset, but it must be very easy to switch between different model architectures. And you can see from the example here that switching between a ResNet 50 model architecture and an TFLite Lite 4 model architecture is just changing one parameter when you train on your model. So it's super simple. We currently support image and text classification use cases, but new use cases such as object detection or question and answers are coming pretty soon. And once you have a working TensorFlow Lite model, the next step is to share it with your mobile app teammates and have them to integrate it into your mobile apps. Model metadata is a new feature that makes model sharing and deployment much easier than before. So it contains both human-readable and machine-readable information about what the model does and how you can use the model. And here's the one example of metadata for an image classification model. And first, you can see that there's some general information about the model, such as the name of the model, the description, the who's create the model, and the license, and so on. And next, it contains information about each input and output tensors. For things like, for example, the name of the input tensor, description, what type of content that it takes. So in this case, the model takes an input of an RGB image. And then things like stats, which is, for example, like contains information like max and min, so that you can normalize your input accordingly. And then it also can contain associated files. And in this case of an image classification model is a list of human readable labels for the classes that the model can take. And you can add the metadata into your existing TensorFlow Lite model using our Python tool. The nice thing is that you can include all the associated files, such as the label files that I just showed you, into the TensorFlow Lite model, so that it becomes like one package and you don't need to distribute multiple files. And the nice thing about this is that the new model format that contains both the model itself and the metadata and the associated files is also compatible with previous version of TensorFlow Lite interpreter. Then another benefit of having the metadata in your model is that you can build tool to pass the metadata, and you can generate the application code to make it very easy to integrate the model into mobile applications. So we released a code gen tool that supports generating Android code from the metadata, and it's currently only support Android, but we plan to expand it to other platforms such as iOS in the future. And next, let's see in details how the Android code generation, Android code gen will benefit. So inference, running inference is more than just a model, right? it will include steps like pre-processing, post-processing, and data conversion. So here are the steps that you needed to do when you run inference with a TensorFlow Lite model in a mobile app. First, you need to load a model, and then you have to transform your input data into the format that the model can consume. And then you run inference with the TensorFlow Lite interpreter. And finally, you process the output result. Without TensorFlow Lite's support library and the code gen, you will have to write a lot of boilerplate code to use the model, such as loading the model, and then converting the native Android native bitmap format into a RGB float array that the model can consume. And then after you run inference, and you will have to convert the output into a human readable format. So with CodeGen, you can see that the wall of code can be compressed into just 5 lines of code that you're seeing here. And the CodeGen, what it does is read the model metadata, and then it automatically generates the Java wrapper with the model-specific API. And it also generates this code snippet for you. And it can make it very easy to consume a TensorFlow Lite model without any machine learning expertise. What you can see here is just like there's no machine learning code here. It's just take the input, load the input as a bitmap, and then you get the output. And your mobile developer teammates must be very happy now, because they no longer need to maintain a chunk of complex machine learning logic like what I've shown you earlier in the apps. And yeah. And also, we are working to integrate the CodeGen into Android Studio, so that you can generate the Java model interface for your TensorFlow Lite model by just import it into Android Studio. And you can try it out right now in the currently version of Android Studio. And now we have integrated the model into the app. And the next step is to tune its performance. So we have launched a TensorFlow Lite profiling tool that can have you quickly identify performance bottlenecks and to fix them. And the TensorFlow Lite can automatically log the performance data that is compatible with Android chasing tool. And you can explore your TensorFlow Lite model performance with Perfecto, which is the new standard profiler in Android 10. And you can look at the overall TensorFlow Lite inference, as well as like ops level events on the on CPU and GPU delegation. It can be a little bit hard to see here, but you can see that we have ops level performance here. And Perfecto also supports profiling of heap allocation for tracking memory issues. So it's really a powerful tool to have you troubleshoot your performance bottleneck, performance issues, and fix it. And now, as your TensorFlow Lite model is integrated in your mobile app, you are ready to scale it to billions of mobile users around the world. TensorFlow Lite works across platform, from mobile OS like Android and iOS to IoT devices such as Raspberry Pi or microcontrollers. And more than that, TensorFlow Lite also supports a broad range of hardware accelerators that are available on each supported platforms, so that it can achieve the best performance with your model. And recently, we added support for 2 new types of hardware accelerator. The first one is to support a greater range of Android devices, especially in the mid and low tier range. So we are working with Qualcomm to develop a delegate for the Hexagon DSP. And this delegate can speed up model inference from 3 to up to 25 times. And this enables acceleration for most Android devices running Android O and below. And this also works with newer Android devices. But for newer Android devices, we recommend that you use the NN API delegate. To use the Hexagon delegate, you only need to add 2 lines of code. First, to initialize the Hexagon delegate, and then it passes to initialize your TensorFlow Lite interpreter. Pretty simple, right? And second, for Apple devices, we have announced the CoreML delegate, which can accelerate floating point models in the latest iPhones and iPads. Technically, this delegate can run on iOS 11 and later, but to get the performance benefit, the delegate should run on Neural Engine. So Neural Engine is the dedicated hardware to speed up machine learning models, machine learning computation on Apple processors, and it is available on Apple devices with A12 SoC and later, such as the iPhone XS. And when you use the Neural Engine, you will be able to observe up to 14 times of speed up compared to CPU execution. And just like the Hexagon delegate, this is very simple to use CoreML delegate. You just add 2 lines of code. And the key goal of TensorFlow Lite is to make your models run as fast as possible on all supported hardware, including CPUs, GPUs, and so on. So we have made a lot of serious investment on all of those fronts. And recently, we have significantly improved the CPU performance. We added OpenCL support for faster CPU acceleration. And we also have full support for all Android Q and NN API ops and features. And to give you a quick sense of those improvements, let's compare our performance at Google I/O last year and today, which is less than a year, right? And in these examples, we use MobileNet V1. And you can see a huge reduction of performance, a huge reduction of latency that can be observed across a wide range of models and device and hardware accelerator. It's the performance improvements is visible on a lot of devices from low end to high end. And what you need to do is to take advantage of these improvements is that you just need to pull the latest version of TensorFlow Lite, and you don't need to change anything in your app. Well, so they were all the TensorFlow Lite bits that we announced at that summit. And I think probably many of you feel a little bit overwhelmed because there was a lot of content. And if you want to take time and go through it again, please check out our blog post that summarize all the bits that I just shared with you. And we're going to post it on the TensorFlow blog next week. So make sure that check it out. And last but not least, TensorFlow is an open source software, and it's very important to TensorFlow that we have a lot of contribution from the community to make TensorFlow better. And in the case of TensorFlow Lite, we are looking to get contribution from the community in terms, like, for example, you can have us to write tutorials for TensorFlow Lite. Some top of mind tutorials that we hope to see from the community is some cool integration with teachable machine that to show people who are new to machine learning, for example, mobile developers, on how easy they can create a TensorFlow Lite model with teachable machine and integrate that into an Android, a mobile app. And we also hope to see end-to-end object detection and image segmentation tutorials for TensorFlow Lite that goes all the way from training a model and convert it to TensorFlow Lite and deploy it into a mobile app. And another area that we hope to see more contribution is that you can have us to convert popular TensorFlow models that is open source by the community. There's many of those models on GitHub, and you can try to convert them to TensorFlow Lite and write sample apps that use those models. Okay, that's all of the content that I have for today, and thank you very much for your attention.
Hey Khan, this is Sayak this side. So we have got a couple of questions. So should we take them one by one?
Yeah, sure.
So what I'll do is I'll share the questions on the screen itself so that the participants have some good, so this is the first question.
Does performance of TensorFlow Lite improve with better specs of phone? For example, iPhone with better processor and RAM, can we expect better performance, and how do you scale with TensorFlow Lite, TensorFlow in computer? Okay, so this is a very good question. TensorFlow Lite support multiple hardware accelerator. So better processors can mean different things. If you run the model on CPU, then definitely a better CPU will give you better performance. I don't have a good a graph to show you here, but you can expect that with every new generation of phone, for example, from Pixel 3 to Pixel 4, you will see better CPU performance. The difference between GPU performance is actually very different from CPU, right? So and even within GPUs, there are multiple ways to use TFLite delegates. You can use it with OpenGL. You can use it with OpenCL, and on the same device, if there are devices that support both OpenGL and OpenCL, and you will see that just by having OpenCL support, your model will run way faster than OpenCL. And also there are neural engine on the devices, such as on Pixel 4 we have the Coral chip on the device that you can access it through the NN API. And even if the CPU performance doesn't improve that much, but having a device with a neural chip, an NPU, neural processing unit, then you can expect a lot of better performance. Then in terms of RAM, actually, as long as your model fit into RAM, I don't think that the performance will change that much if you have more RAM. And how do you scale with TensorFlow in computer? Actually, I don't really get this question. But if I assume that it's about how to run TensorFlow Lite on PC. And actually, TensorFlow Lite does support x86 architecture, but it's not optimized yet to run on a computer. So we may see not very optimal performance. Yeah, I hope that answers this question. Okay, so next one, do we have the option to export and integrate with third-party API of Ccpoa or AWS? Sorry, I don't really understand what this question means. Okay, so it seems that the question is about can you export TensorFlow Lite model and run with other frameworks? Then the answer is actually no. I think there are some conversion path of going to ONX, but it's not like an offshorely supported path, and there might be quite a lot of like difficulties around ops not being supported and so on. Okay. So there's no tutorial for converting object detection and segmentation models from TF 2.0 to TFLite. Yeah, that's a very good question. So we are aware of the problem that there's no tutorials on object detection and segmentation for TF 2.0. So I think the blocking issues here is not because TFLite in TF 2.0 doesn't support this model, but it's more because the blocker is on getting the existing object detection and image segmentation models that is available in TensorFlow 1 and migrate that to TensorFlow 2. It's taking a little bit long time to do it. So, but we are already working on that. So stay tuned. What about the devices that run on Mediatek K? I don't recognize the first two chip, but I guess Exynos is the Samsung chip and the GPU counterparts. Actually, it's pretty hard to have a blanket statement on different chips, but we have the TensorFlow Lite benchmark tool that you can run your models on a physical device and measure the performance of the models there. So I would recommend you to check out the TensorFlow Lite benchmark tool and measure your model performance on the device that you care about.
So thanks, Khan. I think could we take two more questions? I mean, and we can then conclude by call it a day of. Can we take two more questions?
Yeah, sure.
Yeah, cool.
Can one train a network across multiple phones concurrently and in a parallel using TFLite over arbitrary protocols? Okay, so currently TensorFlow Lite, it's still work in progress to make on-device training possible. We do have a very experimental demo for on-device training right now, but it's still a lot of work needs to be done. And unfortunately, we don't have a native support to train a network across multiple devices. But it's not TFLite, but there's another TensorFlow product called TF Federated, which I think might be a better fit for this use case. Recently, I turned my TensorFlow model object detection into TFLite, and I tried to run on my React Native app. My model failed to run. Can we get more documentation in the near future? So React Native, we are aware of that is a very popular platform. But unfortunately, we currently don't have enough bandwidth to support non-native platforms such as React Native. So we rely on the community to bring support to those platforms. And another approach that you can try for React Native is that you can take a look at TensorFlow.js and see if your model can run with TF.js. Maybe that would be easier to integrate that into a React Native apps. I haven't tried, but this is a guess.
So thanks, Khan. I think that was a pretty informative session for both the mobile developers and also the deep learning folks that are looking for optimizing their models. Because in my work as well, you might know we use TensorFlow Lite quite a lot, and recently I've been exploring other ways. I mean, the quantization aware tooling that was recently announced. After that, plugging TensorFlow Lite in to do all the jazzy stuff. I mean, instead of doing the post-aware quantization that TensorFlow Lite already supports, what if we could go one step further and do the model quantization aware training and then plug in TensorFlow Lite? So I'll keep you posted anyways. And we have also, shared the survey link that you shared with us. So we'll be sharing that as well. So again, a ton of thanks to you from the TensorFlow user group Kolkata. And for the folks that wants to get in touch with us, here is where we would share all the necessary information of this session, so that you can get in touch with Khan via Twitter and share your feedback on TensorFlow Lite and any feedback you might have for us as well. Also, Khan, there was one question regarding whether the slides will be shared or not, but I guess you already shared that next week there will be a blog post on the TensorFlow official blogs, right?
Yeah.
Okay.
So I just want to echo what Sykes just talked about the survey. We love to hear from the community on what you think about our new features and how we can improve them to make it better for our users. So please take the survey and give us your feedback. Thank you.
Thanks, Khan, again. So finally, I think we can call it a day off. Thanks wholeheartedly and see you soon.
Yeah, thanks everyone for attending, and thanks Sayak and the TFUZ Kolkata group for organizing this very meaningful opportunity.
Yeah, sure. Bye.
Bye.
So folks, that I think that was a pretty informative session for a number of things, I believe. So we have got a number of exciting things going on in TensorFlow user group Kolkata. So you can check all of these things out from this website, and you can anyway see all our coordinates in the screen itself. So feel free to give us a check. There's this cool contest going on called Tweets on TF. If you have got the power to explain machine learning concepts briefly, you can take part in the contest and stand a chance to win exciting digital goodies. So with that, I'll not take your time, and I think we can conclude now. And thanks for attending this session. Thank you. We'll see you soon.